Okay, so just now we looked at the different formulas for area as well as perimeter for the different figures that you need to know. Okay, so let's go into some example questions. Okay, where you need to make use of some techniques to answer the questions. Okay, first technique, using two formulas of triangle to find perpendicular height slash length. Okay, so in this triangle ABC, okay, where AB equals 5 cm, BC equals 12 cm, and AC equals 13 cm. Okay, so whenever you have this kind of questions in the exam, okay, first things first, when you see your diagram, if the value is not written for you but is given to you, okay, always write it down first. Okay, so write down the 5 cm, okay, BC is 12 cm, and then you have AC which is 13 cm. Okay, so we know the shortest distance from B to AC. Okay, so whenever you are asked for a shortest distance in a triangle, from a point in the triangle to another line within the triangle itself. Okay, put a star here. It is, you are always looking at the perpendicular distance from the point to the line. Okay, this is something that exams like to test you on. Okay, or the concept that exams like to come up with. Okay, so which means essentially I can say both of these are 90 degrees. Okay, then this triangle ABC itself. Okay, the notes did not annotate. Okay, so can you add in for me? Okay, this is also 90 degrees. Okay, so essentially, what do they mean by using two formulas of triangle? Okay, I'm using your formula for area of triangle where I have two methods. Okay, my first method, okay, look at your right angle here. Essentially, your area of triangle is half times base times height, right? So I have half times the base of 12 times the perpendicular height of 5. Okay, which is what you have here. Half times 5 times 12. Okay, which is the area of this triangle. But I also have another way of calculating this area of triangle where this, I can take this AC as my new base and my height as this new line that is drawn for you in the triangle. Okay, where they label as H. Okay, so half times 5 times 12, which is the first way we looked at, is equivalent to half times 13 times H. Okay, then from there, just move your terms around, okay, and work out for H. Okay, so this is the first technique where you look at your triangle and use two different formulas. Okay, not say two different formulas, sorry. I correct myself. Okay, two different ways of looking at your formula of area of triangle. Okay. Okay, so maybe you can just add the notes here, formula of area of triangle. Okay, so this is your first technique. Let's look at the second technique. Okay, knowing two equivalent ways of using area of parallelogram. Okay, so same thing. Okay, just that now we are looking at a parallelogram. Okay, so in this diagram, ABCD is a parallelogram. Okay, AB is 15. BC is 4. Okay, AE is 11. Okay, AE is perpendicular to the line BE itself, and DF is perpendicular to BF. Okay, so in this case, they have written down for you all the values as well as marked down the right angles. Okay, but for parallelogram, what you can do on your own diagram as well, okay, is to mark out the the parallel lines. Okay, so that you know for on your own as well. Okay, so they don't have to always to look back to the question itself. Okay, so area of parallelogram. Okay, if you remember, for area of parallelogram is base times height. So the most straightforward height that I have, okay, which is AE itself. Okay, so why is that the case? Okay, so normally for parallelogram, we will look at the outer height. Okay, where in your formula, if you recall, okay, let me draw it out here for you all. Okay, so assuming this is my parallelogram, okay, we look at this perpendicular height outside, okay, which is essentially in the diagram of the question, okay, is this height here from D to E. Okay, but okay, D downwards to the line here is the same as A to E. That is why I can make use of this as my perpendicular height, okay, which is just 4 times 11. Okay, the base of 4, perpendicular height of 11. Okay, that is for part 1. Part 2, okay, find the length of FD. Okay, so another way I can use to calculate my area of parallelogram is if I use this length of BA as my base. Just now we use BC as the base. Okay, so now we use the longer side of BA as your base. So if this is my base, naturally FD here would be my perpendicular height. So 15 times FD, or the length of FD, is also equivalent to the area that we calculated earlier. Okay, then from there, just divide the 15 over, you get a value of FD, which is 214 over 15 cm. Okay, so essentially you are looking at your area in 2 different forms as well in this case for your parallelogram. Okay, let's look at the next one. Okay, technique 3, finding one unknown length of a trapezium. Okay, so in the diagram itself, okay, you have a quadrilateral. Okay, how do you identify that it's a parallelogram? Okay, because they tell you that QP is parallel to RS. Okay, so when you have you have 2 sides that are parallel like that. Okay, and then you have 2 slanted lines down. Okay, this is your trapezium. Okay, and then they gave you the heights, or not say the heights, the different lengths here. Okay, you have PQ, RS, PS, TR. Okay, which are all labeled for you here. Okay, so part 1, state the special name of the quadrilateral. Okay, so this is the trapezium as we went through earlier. Part 2, okay, find the area of the quadrilateral PQRS. Okay, so if you remember, for area of parallelogram is half times A plus B times height, where A plus B is the sum of your parallel sides. Okay, so area of PQRS. Okay, so let me cancel this out. Okay, let's just work it out using the formula that we have learned. Okay, which is half times, okay, what are the parallel sides that you are working with? Okay, 5 and 9. Okay, so half times 5 plus 9 times the perpendicular height, okay, which is shown to you here. This is the perpendicular height of 5 cm, your TR, times 5. Okay, key this into the calculator, you will end up with 35 cm. Okay, lastly, okay, in another trapezium ABCD, where AB and CD are parallel sides and CD is twice of AB. Okay, find the length of CD if the height is 5 cm and the area is the same as PQRS. Okay, so maybe without a diagram it is hard to visualize this. So let's try and draw a diagram for this. Okay, parallelogram ABCD. Okay, same thing, let's draw a trapezium. Okay, let's draw another trapezium. Okay, I label it ABCD. Okay, let's put down the information that we know. Okay, AB is parallel to CD. Okay, I know CD is twice of AB. So since we don't have a value, let's use a variable to represent it. Let's say I put AB as X, which means CD must be 2X because 2 times of it. Okay, then we also know, okay, the length of CD if the height is 5 cm. So this height they're talking about is the perpendicular height, which means if I draw a line down from here, okay, 90 degrees, this value here is 5 cm. And then the area is the same as PQRS, which is what we calculated earlier. So I'll write the 35 cm square here. Okay, so same thing. Okay, always write out all your information in the diagram that you have, so that you don't have to always refer back to the question for the information. And I just need to look at the diagram, I have everything I need. Okay, so how do I find the length of CD? Essentially, I need to solve for this unknown of x. Okay, so if we use the area of your trapezium, because I already have a value to work with, 35 cm squared, okay, of half times 8, so your area is half times sum of parallel sides times height. I will have half times x plus 2x times 5, which is your perpendicular height, equals to 35. Okay, simplify what you have. You will have half times 3x times 5 equals to 35. Okay, so expand the bracket, 15 over 2x equals to 35. Okay, so now you can solve for x directly. Okay, just bring the 2 over, multiply by 2, and then divide by 15. Okay, so 15x equals to 70. Okay, x equals to 4.2 over 3 cm. Okay, which is what you have here. Okay, just that I wrote it out in a broken down form for you. Okay, step by step. Okay, so please copy this down. Okay, then in the notes itself, also the answer is in an improper fraction. Okay, you always leave your final answers in a mixed fraction, which is your simplest form. Okay. Okay, lastly, okay, your last technique, okay, of using your radius of a circle itself. Okay, so the diagram shows a circle of a diameter of 14 cm, which is given to you. Okay, inscribed in a regular hexagon. So regular hexagon means all of the sides of the hexagon are equal. Okay, all sides are equal. Okay, that's what is meant by a regular hexagon. Okay, of 8.08 cm each. Taking pi to be 22 over 7. Okay, so this is what I mentioned earlier. Okay, if they give you a certain value of pi to use as, okay, use this value here. Calculate the area of the shaded region. Okay, so essentially the technique of doing this question is to find the area of your hexagon minus away this area of circle that I don't want. Okay, so there's an additional formula that you need to use here. Okay, so just write this down at the side. Okay, your general formula of area of hexagon. Okay, is 3 square root 3 over 2 times s squared. Okay, s is the length of a side in a hexagon. Okay, so this is an additional formula. Okay, you're not required to know this. Okay, just that in this question, this is what they are testing you on. Okay, so I'm giving you the formula. Okay, so you have area of hexagon here. Okay, 3 square root 3 over 2 times the square of your side, which is 8.08. Okay, you work out to have this value here. Okay, so they've written out everything here in the notes. Okay, but usually in your exams, you just need to write up to 5 significant figures. Okay, and because this is not your final answer, this is just part of my working. Okay, always leave it in 5SF first. Okay, then you don't have to run out 3SF. 3SF is only for your final answer. Okay, then next you calculate the area of the circle, which is pi r squared. So 22 over 7 times 7 squared. Okay, you get 154 cm squared. From there, you just subtract the area of hexagon from the, subtract the area of circle from the hexagon. Okay, which is this value here minus 154. Okay, end up with this value here of 15.68. Okay, just help me change this answer to a 3SF value, sorry. So you should get 15.7 cm squared. Okay, can? Okay, so those are all the different ways you can make use of your formulas. Of course, sometimes questions in the exams, they might give you in a different form. Okay, but always fall back to your formulas that you have learned. Okay, then see how you can apply them. And then if you are given a question where the diagram is not given out or drawn out for you, okay, do what I did for you in technique 3 or example 3. Okay, draw out the diagram on your own. Okay, make your life easier so that I don't have to constantly be visualizing. I can just see from the diagram that I have drawn. Okay,